a cubic function, right? How do we know it's cubic? Well, they tell us, and it's the highest power of x is x cubed. The coefficient of x cubed is a positive number, so we expect it to be a positive cubic, so having this type of shape, or this type of shape. And our task is to find the equation of the tangent to the curve at x equals 2. So for example, if this point here is at x equals 2, the tangent is the line that has the same gradient as that point, and is in the form y equals mx plus c. Right, equation of a straight line. So a few steps to get there. So step 1 would be to find the gradient function f prime of x, and we need the gradient function so that we can then find the gradient when x is 2, because that is the m, right, and our y equals mx plus c. That's the gradient of the tangent line. And then finally we need to find the y-intercept plus c in order to find the equation of the tangent line. Y equals mx plus c. Alright, so that's our game plan. So if you haven't tried any of that yet, do try it yourself, but we'll go through it together now. So step 1, finding the derivative, f prime of x. Looking at the first term, we have x to the power of 3, so the 3 multiplies out the front, so we get 3 halves, or 3 over 2, and then we subtract 1 from the power. So 3 minus 1, which becomes to the power of 2. With the second term, there's an x to the power of 1, right, when it's not written, so 1 multiplied by a half is just a half, and we subtract 1 from the power, so x to the power of 0 becomes 1, so we're left with half. Right? Another way to remember that is the derivative of a constant times x is just that constant. That is the gradient. Alright, so we found the gradient function. Next up, we need the gradient of the tangent at x equals 2. So we substitute in x equals 2 into our gradient function. So in for x goes 2, and so we're left with 3 over 2, 2 squared is 4, plus a half, 3 halves times 4 is 12 halves, plus 1 half is 13 halves, or as a decimal, 6.5. So a reminder, this number here, 6.5, is the gradient of the function f at x equals 2. It is also the gradient of the tangent, because it is tangent at x equals 2. Alright, and lastly, finding the equation. Right? To do that, let's list out what we have so far. We have y equals 6.5x plus c. Right? Just a reminder, m is what we worked out, and we're looking for c. So two common methods of finding c. You could either use this form, y equals mx plus c, or you might have seen the point slope form before. Either works. I'll use y equals mx plus c. So to find c, you'll notice we have one equation but 3 unknowns, so we need to substitute in a point. Now, what point lies on the tangent? We know x equals 2 is half of a point, but to get the y value, x equals 2, to get the y value, we need to use our original function, because the tangent intersects the function at that point. So actually, before we can find c, we need to find the point on the tangent line. So the original function, when x equals 2, we have half times 2 cubed plus a half times 2. What's that? 8 times a half is 4, plus half of 2 is 1, which gives us the point x equals 2, y equals 5. Right, so that's a point on the tangent line. That point right here. Now, with that, we can solve for c. So we know the x value. Running out of highlighted colors here. The x value of 2 goes in for x. The y value of 5 goes in for y. So we get 5 equals 6.5 times 2 plus c. So 6.5 times 2 is 13. Subtracting 13 from both sides, we get c equals -8. And finally, putting it together as an equation, y equals 6.5x minus 8 would be the equation of the tangent line. Alright, so let's recap this one real quick, and actually I'll show you how to do it on your calculator to check your answer. So we were given a cubic function, asked to find the equation of a tangent at a certain x value. We found the gradient function, so step 1, found the gradient function, and doing that is actually the achieved part, just finding the derivative. We then use that to find the gradient of the tangent, right, of 6.5. We then went on to find the equation of the tangent. However, we needed to find the corresponding y value, so we substituted 2 into the original function to give us the point of intersect at 2, 5. Using that point into our y equals mx plus c, we solved for c and then stated our final equation. Alright, so bonus if you stuck around. If you want to do this in about 30 seconds on your calculator, here's how. So put in f of x, so 0.5x cubed plus 0.5x, right, or half. You may need to turn this option on, so shift menu, scroll down to derivative, make sure that's on. For my calculator it doesn't work when it's off, but it's an emulator so it's a bit different. So we have our function, we hit draw. You can see, oh there we go. So we have our cubic. Now to get the equation of the tangent line, you want to hit sketch, so F4, and you see tang, T-A-N-G, short for tangent, hit tangent, and now we want it at x equals 2, so we push 2 and hit execute. And then, so that's taken us to the correct point, and then if we hit execute again, boom, it's sketched in our tangent line and given us the equation y equals 6.5x minus 8, which is exactly what we got. So good job, us.